Hello students, welcome back into my channel. Now we are going to learn an important topic in physics A level regarding centripetal acceleration and centripetal force. Okay. Before we discuss several questions and find the solutions of that questions, firstly, we need to understand the understanding of centripetal acceleration, centripetal force, and later regarding the angular velocity. Right. But we will begin with centripetal acceleration and centripetal force. Centripetal acceleration is the acceleration experienced while in uniform circular motion. Yeah, so this acceleration types is accelerations happening on a circular motion. So the motion form of the centripetal acceleration is the circle. It's the circle form. Right. Next, it always points toward the center of rotation, of course, because um, and this acceleration and force towards to the center of the circle, towards inside the circle, while the velocity, the tangential velocity direction to outside of the circle. Next, the centripetal force is the force acting on an object in curvilinear motion directed towards the axis of rotation. Okay, correct. Or center of curvature. Yeah, that's directions of the force is always to the center of the circle of the center or the center of the rotation. Centripetal means towards the center. Okay. Now look this figure, these illustrations when this athlete uh, will throw this hammer. Okay, firstly, uh, he firstly this hammer rotating. Yeah, he will rotate this hammer surrounding his body. Then, if we draw the hammer movement, it becomes like this. Yeah, the hammer movement like a circle. And then the if this object is a hammer, look at the center force towards to the center of the circle, while the velocity or tangential velocity uh, direction to the outside of circle. So centripetal force and centripetal accelerations direction towards always to the center of the circle. And the formula to calculate uh, the centripetal force and the centripetal acceleration, if given uh, tangential velocity, yeah, the formula is this one, okay, Vt squared over r, okay, this one. And if given angular velocity to calculate centripetal acceleration, we should using this formula, okay. Meanwhile, the unit of centripetal acceleration is meter per second squared, tangential velocity meter per second, radius in meters and angular velocity in radian over second squared. So how about centripetal force? The centripetal force formula, if given velocity, the tangential velocity, the formula is one, m times v squared over r, which m for mass, v for velocity or tangential velocity, f for centripetal force, r for radius of the circle. If given angular velocity, the formula F equals m times omega squared times r. Okay, while omega is angular velocity. Right. Now let's we start to discuss question. Number one, a pilot of mass 70 kg pulls out of a dive following a circular path of radius 1,800 meters at a velocity 125 meters per second. If we consider the pilot at the bottom of the dive, which the plane is momentarily level, calculate this acceleration. So identify first this question, which m equals 70 kg and r radius 1,800 meters, okay, and tangential velocity equals 125 meters per second. Okay, and we're going to calculate AC or centripetal acceleration. Centripetal acceleration formula Vt squared over r means 1,800 meters. Oh, I mean this one 125. Sorry, 125 meter per second squared over 1,800 meters. Okay, and how much? It's gonna be 15,625 meter squared over second squared. Okay, for 1,800 meters. So meters, one. And if you divide it, becomes 8.68 meter per second squared. Okay. Yeah. So the solution, the answer is 8.68 meter per second. squared. Yeah. This formula centripetal accelerations because of using this formula. Okay, it's fine. And if you will calculate uh, the centripetal force, okay, centripetal force F or FC, M times T squared over R. Okay, and you may submit M 70 kg, VT 125 meter per second, and radius 1,800 meters. You may calculate that. Yeah, this is your part. All right. Next, number 2. A jet plane traveling 125 kilometer per hour. Look, that the unit is in kilometer per hour. Pulls out a dive by moving in an arc of radius 1,500 meters. Calculate the plane's acceleration. Right. So identify first that the velocity or Vt equals 120 kilometer per hour, and then our radius equal one sorry 4,500 meters. Okay, but you have to convert this radius 4,500 meters becomes 4.5. You have to convert into kilometers because the velocity in kilometers. So we should determine the radius. Convert the radius becomes kilometers. Okay, follow this velocity, the tangential velocity, to make easier the calculation. Now we are going to calculate AC. Okay, so AC or centripetal acceleration, Vt squared over R, or it's not 50, it's 125, 120, sorry, 120 kilometers per hour squared over 4.5 km, right? And then after that, uh, we should calculate uh, 14 14,400 4.5 is km per hour squared. Okay. And how much? Let's find it. Oh, 3,200. 3,200 km. Yeah, 3,200 km over h squared. Next. Number 3. Care of mass 1000 kg travels around a level curve of radius 40 meters. If the maximum frictional force that can be exerted upon the car by the road, determined by the coefficient of friction between the tires and the road, is 7,000 newtons. How fast can the car travel without spinning out? All right. As usual, uh, we should, okay, we have to identify first mass, 1000 kg, and radius 40 meters, and then it means it is F, force. Okay, force, force 7,000. Sorry, I mean 7,000 Newton. Okay, 7,000 newtons. Then we're gonna calculate Vt. Okay, so Vt, uh, we have to simplify first the formula that F equals, yeah, if given velocity, m Vt squared over r. Okay, and if we simplify, if Vt is the subject, if Vt is the subject, we may arrange this formula becomes F times R over M. Okay. This Vt squared equals V times R over M, or Vt equals Vt equals square root okay. Yeah, Vt equals square root F times R over M. Yeah. Yeah, okay, we're gonna apply this formula. Okay, next. And then Vt equals square root, how much? F, F equals 7,000 newtons, 7,000, nice, sorry, 7,000 newtons times 40 meters. Okay, over mass 1,000 grams, 1,000 kg, I mean. Okay, and it becomes uh, yeah, divided 7,000 divided by 1,000 equals 7. So 7 times 40 equals 280, 280. Okay, 280 divided by 1, 280. And unit is in Newton. Okay, Newton meters uh, kg. Okay, so I will simplify this unit. So recall that one one Newton, okay, 1 Newton meters per kg. I can simplify for this one uh, on this space. Okay, on this space, orbital this space. Okay, in this space that for Newton meters over kg, it may simplify becomes uh yeah, Newton 1 Newton equals 1 kg times meters per second square. Yeah, that 1 Newton equals 1 kg meters over second square. Okay, times m times meters over kg. Okay, kg divided by kg equals 1, and meters times meters equals meters square over second square. Okay, so this velocity equals square root 280, okay, 280 meter square over second square. So square root 280 equals 16, 16.73 meter per second. Okay, for a 25 kg boy is riding a merry-go-round with a radius of 5 meters. What is the centripetal force on the boy if his velocity 6 meters per second? Okay, identify first. So M equals 25 kg, and then R equals 5. Okay, and then Vt, acceleration velocity, the velocity, not acceleration velocity, the angular, the velocity, sorry, the tangential velocity. The tangential velocity is 6 meter per second. Okay, and we're gonna calculate force. How much force? Okay, force or uh, centripetal force. Yeah, right. Recall that force, the centripetal force formula was mv squared okay, divided by R, and then M, yeah, 25 kg times V squared. Yeah, it means 60 at 6 squared equal 36. I mean, yeah, 36 meter squared over second squared over R, 5 meters. So 25 divided by 5 was 5. Yeah, 5 times 36. 5 times 36 equals 180. Yeah, 180 kg meters over second squared. I recall just now I have explained that 1 Newton equals 1 kg meter per second squared. So the final answer is 180 newtons. Yeah, so next, the, sorry, centripetal acceleration, centripetal force, and angular velocity. Now, we're going to discuss regarding angular velocity. Angular velocity with centripetal force and centripetal acceleration. As I explained that in centripetal force and centripetal acceleration, and there is angular velocity inside the formula. So what is the angular velocity? Angular velocity is defined as the rate of change of the angular position of a rotating body. The angular velocity is measured in radians per second squared. This is the unit. Angular velocity is represented by omega. This omega. And that formula I have explained. Formula. And now we are going to discuss several questions. Number one, calculate the centripetal accelerations of a point 7.5 centimeter from the axis of an ultracentrifuge spinning at 7.5 times 10 power 4 revolution per minute. Okay, so we have to identify first R 7.5 centimeters. Okay, and we should convert into meters. If 7.5 divided 100, it's gonna be, yeah, it's gonna be 0.07. Okay, 0.075 meters. Okay, and omega, omega or angular velocity. Okay, angular velocity 7.5 times 10 power 4 revolution per minute. Okay, per minute times uh, 2 pi 2 pi radians, sorry, 2 pi radian per one revolution. Yeah, why this? Because I will convert uh, this angular velocity in revolution per minute becomes radian per second. Okay, so how to convert? We have to multiply by 2 pi radian over one revolution and as well 1 minute over 1 minute. 1 minute over 1 minute as well. But this 1 minute, the denominator, I will convert become second. So 60 second. Yeah. One revolution, for note here that one revolution equals 2 pi radian. Yeah. So actually, this fraction actually, wait, yeah, this fraction equals 1 and this fraction as well 1. Yeah. Uh, I did it because I will, as I told you that I will simplify this angular velocity from the unit in revolution per minute becomes radian per second. So look that minute divided by minute equals 1, and then revolution over revolution equals 1. So 2 pi radian per second. Okay, let's continue. So it's going to be 7.5 times, so 7.5 times 7.5 times 10,000 because 10 power 4 times 2 pi, 2 pi or 2 times 3.4. Sorry, because pi is 3.14. I mean, pi equals 3.14 over 60 radian per second. And if you calculate, let me calculate first. Equals 7,854 radian per second. Okay. Now let's define the acceleration, centripetal acceleration AC equal R times omega squared. So 0.075, okay, meters times uh, yeah, 7,854 radian per second squared. Okay. And if you calculate it becomes yeah 4 yeah 4.63 times 10 power 6. Sorry, so this is 10. Okay, 4 million and so on. And the unit, of course, meter per second square. Okay, sorry, meter per second square. Okay. Number two, if the centripetal force to keep the ball in a horizontal circular loop is 50 Newton, it achieves an angular velocity of 0.25 radian per second with a radius 8 meters. Then calculate its required mass. Still same, we have to identify first that F, yeah, F equals 50 Newton. Then velocity, yeah, or angular velocity, omega, I mean, omega equals 0.25 radian per second. And then radius r equals 8 meters. And we're going to find mass. Okay, mass, how much? So mass, we have to change the formula from F equals m times omega squared times r. If m becomes subject, it means m equals yeah F over force over omega squared times r. Okay, so m equals how much? F 15 newtons. Okay, and omega squared 0.25 radian per second. Squared times yeah r 8 meters. Okay, and if you calculate, it becomes 50 divided by 8 times 0.25 squared. And you may get the solution, the number 25. Okay. For the detailed calculation, you may using calculator for calculate that. Okay, detailed calculation of this. Next, number three, an object of mass 800 grams is whirled in a horizontal circle of radius 5 meters. If it performs 125 RPM, calculate the centripetal force acting on it. Okay, identify first M equals 800 grams. Okay, 800 grams, or uh, convert into kilograms, 0. 0.8 kg. Then R equals 5 meters. Then 125 F frequency 120 120. Okay, 120 RPM. So omega equals one angular velocity equals uh, 2 pi f, 2 pi times f. So 2 pi um, okay, 2 pi times 120 over 60 seconds. Okay, yeah, equals 4 pi 4 pi. And then next, yeah, we can calculate F of force because uh, we will calculate F. Okay. The question is about force. Yeah. Calculate the centripetal force acting on it. So force equals m v squared over oh, sorry, not m v squared, m times omega squared times r. Okay, so it becomes m 0.8 kg times omega uh, 4 pi r, 5m. Okay, 5 meters. And if you calculate, it's gonna be 50. Yeah. So 0.8 times 16 times 5. Yeah. It's gonna be 50.24 newtons. Yeah. I'm gonna fix this is 2. Okay, the square. This is omega. Yeah. Okay. Okay, students, thank you for joining with me in this lesson. Later we we'll discuss several topics regarding A level physics. Thank you. See you.